So today I'm going to be talking about the future of building cross-platform user experiences. If you don't know who I am, my name is Hasan Ahmad. I'm the principal consultant of a company called Aquint Dev 6, and I also co-lead Facebook's Toronto Developer Circle. So if you don't know what Aquint Dev 6 is, we're a consulting business that's focused on implementing user experiences and user interfaces in web applications and mobile applications using web technologies, primarily JavaScript. And this is an interesting topic for us because the modern web has its origins in the browser, which is fundamentally a cross-platform experience, maybe the original fundamental cross-platform experience. And while today's technology for the web has actually expanded far, far beyond just browsers, we can use languages like JavaScript everywhere these days. Cross-platform requirements for the projects we've worked on have always been key for the reason that companies have even been working with us. Sure. So we've been in business for almost 2 decades, and the reality is that implementing consistent user experiences across platforms has been difficult for decades. From all the way back to the 70s and 80s, first computing platforms, personal computing platforms that ever existed. There's always been differences, sometimes driven by hardware, sometimes just driven by design choices. And even if you look at the evolution of just a single platform like desktop computing, there's been so much change in this last couple decades. So you look at original Windows designs, original Macintosh designs, to how far they've come today, and the strategy around designing. Sometimes in the past it was like strategic not to be cross-platform. Things have completely changed. So one example that I love to bring up is Microsoft Office. There are actually so many tools and ecosystems that every user is a part of today, whether you like it or not. Your end users are on multiple platforms. If you look at what Microsoft Office is as a product today, it's actually staggering how many platforms it runs on and how strategic that is for Microsoft as a company. You go back to the early days of Microsoft and Windows, the whole Office product was a differentiator from other competitors in the platform. And Microsoft used that strategically to grow, to not be cross-platform, to be competitive, to be locked in, force people to buy Windows because they needed Office. It was the killer app model. And Microsoft kind of took over, in the 90s, that was a huge strategy. Pretty quickly, they found it really important to be cross-platform and started expanding into Macintosh early on, just a couple years after the first Windows-only releases. But if you look at it today, it's available on everything: Mac, Windows, Android, iOS, web applications. You can get your notifications, or get your emails, and everything on your watches, and everything else. These days platforms emerge so quickly, and the whole strategy around it has completely changed. Microsoft these days is one of the most valuable companies in the world. Recently crossed the $1 trillion market cap milestone earlier this year. So this cross-platform strategy is actually strategic massively for companies. In the past, it was actually the opposite. Companies were creating platforms and building killer apps to drive engagement and use that as a way to sell their platform. But we live in an era now where users are not going to be in one platform, no matter what platform vendors like it or not. You have multiple platforms, everybody does. Even if you are super committed to one ecosystem, there are ways that you have to occasionally interact in other ecosystems. And products these days are naturally thought of as cross-platform in order to kind of last and be meaningful through the decades. So where is all of this going? To get an idea about how this is going to go in the future, let's take a step back and think about how we got here. I want to use desktop computing era as actually kind of a starting point to think about how we built and designed experiences for platforms, and how more platforms have come up and how their evolution and changes have actually changed expectations of users. So, desktop computers. For a computer geek like me, this was a magical time. This was kind of the era where certain hardware user experience was kind of set, a formula. This was the first time personal computing was kind of exposed to the masses. And designing for these platforms is actually really interesting because so much new hardware, so many new paradigms are kind of being introduced to the user at once. You have mouses, keyboards, monitors, disk drives, customizable, upgradable hardware. That's something that's almost gone these days. But back then, users were actually specifying what they wanted in their hardware, changing it all the time, and it was a lot. I mean, there's so much going on here in terms of designing an experience, and this is the era when people were still trying to figure out, should a mouse have 1 button, 2 buttons, 3 buttons? What do they do? How does that interact? How does that change the design? The concept of windowed user interfaces at all. So going from text-based to a graphical windowed-based system where you can layer windows on top of each other kind of became a paradigm that just expanded and is still used to this day. This is where a lot of foundation was set, and it goes all the way back to like the Xerox PARC days. And this is the era where all kinds of categories were created, from PC gaming to desktop publishing. Adobe Creative Suite kind of has its home, its origins in this kind of platform, and development environments, integrated development environments for the implementers and programmers, people like me. Then we entered into kind of a new era with laptop computers, and things started to kind of subtly change. The mouse kind of completely changed, sometimes completely eliminated, and we replaced it with things like trackpads or trackballs, or who remembers that IBM, red nub? It's kind of a unique, interesting thing, but it hasn't really been, it's kind of phased out. Built-in monitors, built-in keyboards, all of these things really started to subtly change how our users interact. I'd say the biggest thing that was introduced here that became a big thing, later on was the concept of mobility. Laptops allowed people to start using their software, their computing experiences away from their desk, away from home, take it on the go, and that's, as we all know, ended up becoming a very big thing. Battery life, this was a concern that really didn't exist in the desktop era, but we have to really think about it when we design for things that have limited battery life. You can't do the same thing, so we started to see, some thoughtful design thinking around how laptops are different from desktops, and do we want to change some things. But from the software side of things, it was largely the same experiences. Almost all of our apps that worked on desktops worked on laptops. We didn't really change too much, even though the form factor changed quite a bit. But I'd say there are a few notable things that kind of came even with subtle changes. I would say definitely built-in webcams. Even though webcams are not new, built-in webcams really changed expectations about communication. Video calling started to become a normal thing to do, just by virtue of webcams being built in by default, so you don't have to actually go buy a webcam for it to be an option, and it just being in your face right there. Just that fact started making people aware that video calling communication can be a normal thing. But really not much other things changed that dramatically. A lot of our software is exactly the same. And I would say up until about 2016, the touch bar on MacBooks was one of the only new things, like actually new innovations from a hardware side of thing, on desktop operating systems. Then things started to really change. Cell phones, I'm not going to talk about smartphones yet. First I want to just talk about the era of the first consumer cell phones, where this is kind of surprising because historically nobody really thought this was going to be the next computing platform. There was just a different device, a different user experience, but a lot of really important things that we take for granted today in computing platforms actually have their origin in the widespread use of cell phones in the first case. So obviously we went much smaller than a laptop, and mobility is much more important than ever. Keyboards, the typing experience, there's a whole redesign here around typing. You don't have a big keyboard, you don't type with 2 hands, you type with thumbs. Is the text readable? Can people be trained? Can people get used to this? These were all open questions at this time. We started seeing, different times of input modes. So some of those early touch screens that were stylus-based instead of touchscreen only. We actually had less power than a laptop, like significantly less power than a laptop. We had less power just in general. Limited internet. So, compared to what you could do on a laptop, these early cell phones barely had any internet. All you could do is pretty much get a call. Later generations started to implement the first cell phone browsers, but they were very limited. They didn't support all of HTML. But the main thing here was the kind of communication and the culture of communication. People being, expected to be available all the time, being in contact all the time. This was something that ended up being really, really important as technology platforms continued to advance. So, now we live in an era of smartphones. And smartphones, this is where we started bringing back our old things, our old apps that we were used to in desktops and laptops. They actually started making an appearance back in our cell phones. So literally, your browser, a fully capable browser, the same HTML5 compliant browser that could run on your desktop or laptop can now run on your phone. Surprisingly, it was much, much worse battery life than a regular cell phone, but it didn't matter. People actually put up with the worst battery life because the power that they got from these modern chipsets was worth it in the long run. Another really interesting design here that kind of just proved out in the long run was going with only touchscreens. Steve Jobs was extremely opinionated about styluses. The famous quote about everybody's got 5 styluses on each hand. And that became a standard. It really took over the industry. The platforms that embraced touchscreen only and ignored everything else were able to iterate on other things much faster because they stopped asking questions about what is the primary input type. Data-intensive applications. So smartphones started doing things that cell phones were never even allowed to do. Like consuming gigabytes of data was not even permitted by carriers in the previous generation. And smartphone strategy, like the vendors and creators of smartphones actually forced carriers to change that, enable next generation networks to allow users to actually consume that amount of data. So they had to create new space and create new expectations in the broader ecosystem to even make this kind of stuff possible. The App Store and the Play Store, this changed a lot. This was really more of an e-commerce innovation than technology. This is nothing that was kind of preventing this from being possible in the past. But very, very important if you think about it, because the business model that emerged from this actually allowed the players in this space that were successful to finance improvements. If Apple and Google didn't have that 30% cut on the App Store, they probably wouldn't have enough money to continue to build all of the features that Android and iOS and all the hardware that Android and iOS support today. Geolocation became a thing that's just fundamental now. Your applications and your software knowing exactly where you are and reacting to that, super important. Speech recognition became normal. It was science fiction up until it just became not science fiction anymore, and people are using it all the time in all kinds of use cases now. High-end photography, push notifications, all of these things, we kind of spent a whole decade learning collectively as an industry what it takes to design a smartphone, what it takes to build applications for smartphones that users like. And it seemed almost like we kind of developed a bit of tunnel vision because we kind of forgot about the old world. People adopted this platform so quickly, stopped using their laptops, stopped using their desktops as much as they used to, and almost sounded like we kind of just decided, like, that's it. This is the interaction model, the ideal personal computing interaction model. Until we didn't, actually. So funny enough, the transition from desktops to laptops, where we just kind of took the exact same experience and packaged it up into a new form factor, that's how tablets started out. For a long time, the design of tablet applications was kind of not very thoughtful. We just took our smartphones and literally sometimes ran the exact same software, to the point that we did something in the early releases of the iPad. sometimes you could just publish your iPhone app to the iPad, distribution in the App Store without even changing the screen size. And slowly we started changing that. But lately, I'd say, today we've started to see some really thoughtful changes in the way that we build an interface for a tablet compared to a smartphone, even though the operating system is the same. Something that's of real interest to me lately is how Bluetooth accessories are becoming so popular with tablets. We're actually starting to bring back some of the things that we threw away in the past. Even though these are touchscreen tablets, like we all learned in the mobile era, styluses and keyboards are coming back. Even Apple ships and promotes these Bluetooth accessories with their tablet computer. It was something that Apple was very opinionated about not doing during the smartphone era. We spent a whole decade changing the way we design interfaces, changing user expectations, getting everybody used to the new way of doing things, and now we're coming back to these new things like Bluetooth keyboards and styluses and acting like they're really new, but they're not. Some of these things are really old, and we stopped doing them. The interesting question behind it is, people are kind of trying to have this debate around content creation and content consumption. A lot of people argued that the shift to mobile computing, smartphones, and tablets took away our ability to create content on these devices. Taking away the keyboard, taking away the mouse. Now you're just viewing things passively. You have less ability to express yourself, less ability to put data into the system than just consuming data. And there's a whole debate around, is content creation kind of, still the same way it was even, 20 years ago, or, keyboards are such an old user interface. It goes back, centuries. So have we even solved the content creation problem? I mean, we have exposed new things. We have speech recognition and we can speak, but we haven't really gotten that deep into this stuff. So that's a picture of my iPad, actually. It looks like a laptop, surprisingly. But I've got a Bluetooth iPad keyboard that almost makes it look like a MacBook. And I study this thing. I think it's really interesting. I've been experimenting with my iPad apps to see if I took this thing that was designed for a touchscreen and put a keyboard back there, how do apps actually respond to this? And you'd be surprised. Some apps, especially the built-in apps that Apple builds, actually detect there's a hardware keyboard and give you an experience as if you were using the same app on your actual Mac OS device. So the Safari browser, for example, implements all of the keyboard shortcuts that are so important to a desktop user or a laptop user on Safari. They just work seamlessly without even knowing about it. It's almost like a hidden feature. And the reason it would be hidden is because you don't even discover this if you don't buy a Bluetooth keyboard and attach it to your device. Some apps actually do this. Some third-party apps, people thought about this. So, for example, the Twitter app will scroll when you press the space bar. But a lot of apps that were designed with touchscreens in mind never even considered the concept of hardware coming back and completely ignoring that experience. So this is something that you can actually use to differentiate to see how thoughtful are the design teams around this. Do they actually capture this? Do they think about what happens when we take a touchscreen device and start to use some of our old input modes again? Another thing that I find fascinating, there's a voice input button on a Bluetooth keyboard for an iPad. This is almost that debate that we're talking about content creation. How do I input information into the system? If I've got a keyboard and I could type it out, why is there a button that allows me to just stop and just press the microphone button and record everything that I'm saying? This wasn't something that you saw on laptops and desktops, even though technically could have. But user expectations have changed. Everybody knows that Siri is available on iOS devices, or speech recognition is so much better than it used to be, that new keyboards and new laptops actually give users the ability to just switch to speaking instead of typing. Another really interesting trend, touchscreen laptops. Personally, I hate when people touch the screen of my laptop. I don't want fingerprints. I had to tell everybody, don't touch my screen when I'm showing them something. But here we are encouraging people to do this. So we have laptops now, true desktop operating systems that are fully touch capable. This is like the opposite scenario of my iPad with a keyboard. It's the mobile operating system that can handle a hardware keyboard. But if you think about what Windows 10 has done, they actually intentionally designed an operating system that can seamlessly switch from a tablet to a laptop with a keyboard plugged in or not, or a Bluetooth keyboard, and with a stylus or a mouse. And that's something unique to Windows. You haven't seen, Mac OS or iOS really jump this far, or even Android and Chrome. Like, there's just been a whole bunch of different opinions in the industry of how to do this kind of thing, and different platforms do it. And if you're trying to build something that's cross-platform, you have to really think about this if you want to be thoughtful about it. Does the design that you came up with make it easy to do this kind of thing? Have you even thought about it at all? Now it starts to get really interesting when you think about, what's going to happen in the future too. So things that are, coming up more and more that are completely different from, our traditional computing platforms. And increasingly, you find that these platforms, they just emerge from surprising places. When you were in the tech industry building computer software for a desktop or a laptop, you never thought that cell phones were going to be the next thing, that we would be building the same software to run in a cell phone. But it ended up happening. It ended up being the case that cell phones got to a point where they could do it, and users ended up liking it, and now it's like the primary computing platform that we target these days. Similarly, there's the chance of this happening in really surprising places with what's happening in the IoT industry, the Internet of Things. So the concept behind, IoT is really kind of an old concept called ubiquitous computing. It's kind of what it was called decades ago, before IoT became the new buzzword. The idea was that, computers are everything and everywhere. There isn't really a device that's a computer that's smart and connected. It just kind of seamlessly switches to a computing platform. So this can be, something like a smart TV, your home thermostat, your car, when you look at things like CarPlay and Android Auto, your smart building, when you look at if you're living in a condo building and, you want to be able to answer a video call from the building entry system on your phone. There's all this technology and all this, computerization of everything that needs to happen for you to do that. It used to be you could only call somebody, but now you can actually have a voice or video call, one way or two way from the lobby to your apartment or your condo. And going further than that in the future, when we have smart city infrastructure one day, where not only just what's happening in your property, but how the entire grid is attached to it, how much power you're consuming, or your city services that are connected in a smart way to where you live. There's all these potential areas where new platforms can come up. And who knows, is it going to be that Apple or Google take over those platforms, or some new company, some new hardware vendor comes up with a new operating system? Because when you look at what happened in previous platforms, like almost everybody who was making cell phones before Apple and Samsung, well, Samsung was one of the only ones that was doing it before, but if you look at most of the cell phone industry, almost all of them are out of it now. And new hardware manufacturers and software developers are in this space. So what if that happens again with IoT? We might have all these new platforms to deal with in the future. So, another thing that's happening increasingly in the future is wearables. So, this is where we're starting to play with, again, another area where platforms are branching out or emerging. So, sometimes it's the existing platforms that are branching there. Sometimes it's a completely new company or idea that's creating a new platform. So let's talk for a second about smartwatches. You've got Apple branching into this with Watch OS, which is technically a new operating system, but integrates nicely with Mac OS and iOS. In the future, Apple might actually turn that into a separate operating system and give you all new SDKs and platforms and tools, or they might not. When you look at some other companies that are entering the smartwatch space, so Fossil, which is already just making regular watches, they actually had a completely different approach to the concept of a smartwatch. They were of the opinion that, being something that is targeting, people's sense of fashion, very subjective. Maybe they hate screens. Maybe they think that's just terrible. I don't want, a digital screen on my wrist. It just doesn't look good. It doesn't match my outfit. It's not my style. Fossil did a really fascinating thing with the Q series smartwatch, where the smartwatch interface looks just like a regular watch, even though behind the scenes there's a computer in there that connects to your smartphone with an app that has your screen and interactivity and everything. Your Q series smartwatch can still track your steps, can still actually let you know when you're getting a text message. It'll just vibrate on your wrist so that you know to check your phone. It's a totally different designed experience than what happened. And actually, surprisingly, Google actually bought this division of Fossil. They actually integrated it into Android. Smart glasses. So, there's a company in Canada called Focals. It was actually Thalmic Labs. They rebranded to a single product. And they're building augmented reality glasses. So these are glasses that are in production now. You can actually buy them. They're pretty pricey. They cost about $1,000. But they can actually display data from your smart systems, from your phone, from your, you can see where your Uber is. You can see your text messages on an overlay on your glasses. This is like, again, another possible computing platform that's going to come with its own systems, its own user experience to think about. Gaze-based input is another whole thing that comes up with head-mounted displays, where your eyes are tracking might actually replace touch-based input or cursor-based input. And voice interfaces, again, from the mobile world, voice interfaces, again, are starting to become a thing that might solve some of these problems. If you think we don't have enough platforms yet, there's still more platforms coming up, even more. So this is a photo I took from Mark Zuckerberg's keynote speech at F8 earlier this year, where he described Oculus as the next computing platform for virtual reality. So let's take a second and think about what's going on even over here. This is, again, another niche area, the video gaming world, where some hardware and some experience is starting to branch out. It's becoming a new platform and may become the next big computing platform. And we have all kinds of things to think about when we design here. The Oculus Go, which is a mobile, wireless standalone headset, which launched last year, was a 3 degree of freedom, meaning it tracks where you're looking but not where you are in space, with a single controller. And the Oculus Quest, which just launched last month, is now in production. It's a 6 degree of freedom head tracking, head-mounted display, which means it tracks where you're looking and where you are in space. Has 2 controllers that have multiple buttons and touch sensitive buttons. So how we input into the system, into this virtual world, is now completely different from just even last year. And even compared to the gaming-based headsets, which were wired, these are completely wireless systems, and they're mobile, and you can take them everywhere. So there's a good chance that this stuff is going to start to become more widely adopted, more mainstream, more accessible. And it's really impressive. But again, there's a whole design thing around this, around capabilities. Eye tracking is something that Oculus is looking into as well. And they're trying to solve the problem of where a user is looking in a virtual world just by tracking how their eyes are pointed in that head-mounted display. So right now, if you want to change where you're looking in a head-mounted display, you have to actually physically turn your head and look. But there's all kinds of fancy things you could do with eye tracking. So for example, in real life, your eyes have a fairly narrow field of view where your brain is actually processing the input signal at a high level. You never notice this because the things that are not directly in this somewhat like 3 degree field of view where your pupils are focused, it's actually kind of blurry. The second you look in that direction, obviously your brain, it's almost like it's re-rendering that in a higher resolution because you're looking at it. It's kind of like a technique that decreases the amount of energy your brain needs to process visual information. That technique can again be applied in virtual reality in one day, decreasing the amount of hardware, decreasing the size, decreasing the battery consumption. But it's not ready yet. According to Oculus, at their conference last year, they said this is about 4 years away. By 2022, their headsets may actually be much smaller because they can do eye tracking. We just don't have the accuracy to do it properly yet. And then there's mixed reality. So some vendors in this space actually have the opinion that we should go for headsets that can mix augmented and virtual reality. And again, it's a whole new world. It's a whole new thing. So hopefully I've convinced you that there are just so many platforms we're already dealing with, and all of these platforms that can come up, and our users are going to start to expect us to be, building our products for. We're going to have to take our products and make sure that they interact in these platforms correctly somehow. You're starting to understand that this is a lot of work. This is crazy. We're already struggling to keep up with cross-platform with just like a handful of vendors and computing platforms, but it's about to explode in complexity in the next 5 to 10 years. So, there's some open questions we should think about. You might notice that a lot of features in these systems are AI-driven. They're using machine learning based algorithms. Voice recognition, for example, face recognition. These things are powered by computer vision algorithms that are powered by AI. And the way that they're built actually requires companies to collect massive amounts of data, put it into a system somewhere and train it. So let's think about this for a second. Is this a good idea for your product? Can your company afford that? Are there concerns around surveillance and privacy when we collect this amount of data to build an algorithm? Who's responsible for maintaining its security and privacy? Have we even thought about that? This is like something that's just kind of a question that emerges out of the design decisions that we make, a technical decision we're going to have to make. Things like location tracking or biometric data that we're going to be able to capture. If you look at things like the Apple Watch, the current Apple Watch, Generation 4, they've launched a capability that goes beyond just reading your heart rate. They wanted to be able to do EKGs. So the idea, that personal computing, it's becoming so personal. You may even be shocked how personal this data is. It's knowing stuff about you that you don't even know. How do we track all this? And then the question is, if you don't think about this stuff, in the future, what if the government creates regulations about this? So we're starting to see just, some early attempts at this, but for example, the data protection regulation from the EU, the GDPR, was kind of the first multinational legislation, in Europe at least, that started to put some rules around how companies collect data, what are their commitments, what are their liabilities, how do we protect users? And before that happened, it was kind of the Wild West. Companies could build whatever they wanted, collect any amount of data, do anything they wanted with it, and now there are some rules. And those rules may not be perfect, but they may change, and we might start to see other regions of the world start to adopt these kinds of rules and policies. So even if you're not thinking about this stuff right now, there might come a time, there probably will come a time when you will be forced to, you'll be legally required to, and our industry, is going to have to adapt to those things. So these are all, big questions that we haven't answered yet. But, I come from the technical implementation side of things. I'm not really a designer. I work with designers, and our company works with designers on a whole bunch of different projects. So I'm assuming I'm talking to mostly designers, and I want to just give kind of a brief overview at a little bit of a technical level how we are dealing with this approach. So all of these platforms that emerge, they always come with some kind of bare minimum native development kit. And your development teams, in an ideal world, if you had unlimited resources, your organization would be able to spin up development teams to target the new stuff that Apple does, new stuff that Google does, new stuff that Oculus does, for example. These platforms that are emerging faster than ever, you'd be able to have development teams that are specialists in those and build them natively. But in the real world, most organizations' resources are pretty limited, especially development resources. So you could easily expend all of your time and money not actually be able to build any products, or your timelines might just be too ridiculous to actually get anything done. So I have to kind of look at this idea of how do we build something that's going to allow me to adapt to these platforms, kind of write something, build something in a reusable way. And this is where we talk about cross-platform implementations. So using technologies that these are usually decisions that your development team makes, whether or not to use a native SDK that's not cross-platform, or using a higher level tool or language or framework that is cross-platform, is going to have an impact on your product's time to market, availability, and these are probably important concerns when you're designing something. Higher level cross-platform implementations, they reduce your risk and they improve your ability to port to other platforms faster. You could do this potentially with one team if they know the right tools and the right technologies. You'd be able to target a multitude of different platforms. This does come at a cost. Obviously, we're not going to be able to be first into a native platform. We won't be able to be the first all the time to consume that new capability from this new platform if we always look for the cross-platform approach. But you're gaining in flexibility when your development team makes these decisions. So let's talk a second for the browser, which is kind of where we started from. We were building web applications and for the browser, we naturally have this cross-platform advantage because browser teams are dedicated to paying attention to all of the hardware and all of the platform changes across the ecosystems, and they give us a nice high-level thing to build on top of. So the next time a browser supports another platform, the stuff that I built there will just work, mostly, a few minor modifications. But for example, I had to make a lot less changes to get my desktop website to work on a mobile device than I did before. I had to do everything natively. Browsers themselves are becoming way more powerful than they ever were in the past. HTML5 and standards bodies, you'd be surprised how much you can do before you even have to go into a native SDK. So, browser-based implementations have been our bread and butter for working with cross-platform products for a very long time. Occasionally, though, you find yourself with requirements that require you to do something that's only available in a native SDK. And, you gotta be careful here. Even today in 2019, say in the city of Toronto, a native iOS programming developer, hourly rates for a contractor that knows that stuff are still pretty high. Let's be realistic about, think about the kind of budgets that you get for your projects and how much money you have. An iOS developer can easily go between $100 to $150 an hour in this city. You quickly start to realize when you see the timelines, the budgets, that you're going to be spending a lot of money to build native things. Not saying don't do it, but I'm just saying let's think about this. There are technology platforms that allow your development teams to use web technology that works across different platforms in a hybrid way. So you can build the bulk of your experience in a reusable cross-platform way and only dip into the native things that you need for desktop applications with a tool like Electron or mobile applications with a framework like Ionic. So if you're working with your development teams, you might want to ask them these questions. You might not typically do this as a designer. Ask your development team, what technologies are you using? What impact is it going to have on how many platforms I can ship on, or what kind of resourcing I'm going to need to actually build these ideas. And there's also non-hybrid approaches, like React Native allows us to use a web technology on iOS and Android and build native experiences without a browser in between. So, let's just recap for a second here. I'm not saying don't build native things or don't hire native developers, because occasionally your products are going to need to do these things. Sometimes you may actually have to go purely native for a product for a short period of time. But as your product, if you have a long-term strategy and you want your product to be around and available in many platforms that your users are using over a long period of time, you're going to need to start thinking about cross-platform architecture. So don't jump into a native implementation or a native SDK blindly just because a new platform has emerged and it's really cool. It's often much safer to wait until there is a cross-platform way to solve these things for cross-platforms. Like these platforms and technologies emerge so quickly that if you try to respond to the latest IoT platform, the latest virtual reality headset, the new cars entertainment system that connects with your apps and your multimedia, you're going to spend your resources probably very quickly and not be able to actually execute. We already find, in the projects that we're working on with our clients, that they're already struggling with the complexity of just where we are today. I'm not even talking about where we're going in the future with IoT and virtual reality and augmented reality. And that stuff is going to make this a lot more complicated and a lot more complex and a lot more expensive. So this idea of cross-platform architecture is going to be very, very important. The other thing is that platforms just emerge so much faster than they did in the past. In the past, we had sometimes a decade in between to get our development teams and our knowledge and experience with a platform into another platform. But we don't have that kind of time these days. Focal's pivoted from their previous product to their existing product in a very short period of time, and it may actually be a big platform. So really think about it. Can you afford to lock yourself into a native implementation? Sometimes you may have to do it, but give it some thought and ask your development teams, what technologies are they using? Are they thinking about cross-platform? Is it possible at a design level for us to work and take advantage of cross-platform implementations? Thank you for your time. That's it.